Hello everyone and welcome back to the Leetcode grind. Today we have 1380 lucky numbers in a matrix. It says here that we're given an m by n matrix of distinct numbers, from which we are to return all lucky numbers in this matrix in any order. Now, a lucky number is defined as an element of the matrix such that it is the minimum element in its row and then also the maximum in its column. The hint is that it is an easy problem, so what first pops up into your mind is likely a viable solution. So reading this problem, we can tell, all right, so let's see, we want the minimum of the row, maximum of the column. We're given the matrix. So why not we just do a first pass and check or accumulate the minimum element for the row and the maximum element for the column. Then we can do a second pass and check if whatever current number we are on is the determined minimum of that row and the determined maximum of that column. Then that's a result, and we can add it to our result array and return it at the end. So let's give that a go. All right. Let's first get the dimensions. We have some number of rows and columns, which is the length of matrix, the length of the rows, 1, 2, 3, and then the length of any of these rows. So in this case, there's 1, 2, 3 columns, okay? And then we can also initialize an array to hold the, in this case, the minimum for the row for that length. So the minimum, so we want the opposite. If we want to find the minimum, then we can initialize it to a high number so that a valid number will overthrow the high number. So let's say that's going to be, it's going to be an array, float in, I think that's what it was, times the length of rows. Now, on the other end, for columns, we're trying to determine the maximum for each column. And the way we can do that is initialize it to a minimum such that the next valid number, really any number, will overthrow it. And the minimum number can be 0 because each number is at least equal to 1 or greater than 1. So let's initialize that to 0 for the length of columns. We of course have our result variable where we can store all of our numbers that are determined to be the minimum for the row and the maximum for the column. And this will return at the end. Okay, now let's do the first pass. The first pass is determine the minimum for each row and max for each column. The second pass will be determine the qualifiers, the winners, the matching, determine result. Okay, so let's do the first pass and say for a row in the range of the count of rows, and for the column in the range of count of columns. And basically we're going through each number in each row. Okay, so our number is matrix of that row at that column. And we say at rows for that nth row, that index row, that's going to be, let's see, we want the minimum of the row. So we want the minimum of whatever it currently is, which is initialized to infinity to start, or whatever current number is. Conversely, for the columns, we're actually looking for the maximum. It'll be the maximum of whatever it currently is at that index, column index, or our current number. And believe it or not, that's pretty much it. At the end of this, for each row at that index, for the length of rows, we'll have the minimum for that index. So in the case of this, just for visualizing, right? So we can tell like the minimum for this row is 3. The minimum for this row is 9. And oh, it looks like it's ascending. I don't know. Okay, that's great. And then for the column, we're looking for the maximum. So what's the maximum for this column, the 0 column? Well, the maximum will be 15. And then the maximum for here will be 16. And the maximum for the last one will be 17. And why don't we just verify? Let's say rows and print columns. Okay, give that a go. And so when we look at the output, we see, oh, output is here. We see that we do get what we expect, 3, 9, 15. Those are the row minimums per row. And 15, 16, 17, the maximum per column. So why don't we continue with our logic and go to the second pass. In the second pass, now all we're basically doing, we did the hard work here. We determined, what's the minimum row, what's the maximum per column. Now all we just do is just do the same iteration for each row for column in range of C. We have some number that is at that cell and at that row at that column index, and say if num matches whatever is the minimum for that row at that same row index and also matches whatever is the maximum at that same column index, then you know what? We found the lucky number, which once again is defined as a number in the matrix such that it is the minimum element of its row. We have the rows, minimums, and the maximum of its column. So that's all we do. We just res.append this number, and at the end, just return it. Give that a go, and submit. And there you have it. And I want to do this more, the time and space complexity, which I'm not too good at right now. But let's see. We have these arrays. So this is at least O of n because the space grows with the size of the input. Okay, just roughly. And then the time, we do another one iteration and another iteration. So that's overall 2n's, which simplifies to n. So I believe this is going to be time and space is linear. Please feel free to correct me down below. And there you go. 1380, lucky numbers in a matrix. Thanks so much. Happy coding and see you next time. Bye.